In 1965, a man stood on a stage at Cornell University, looked out at his audience, and said something that almost no Nobel Prize winner has ever been brave enough to admit. He said, "I think I can safely say that nobody understands quantum mechanics." The man was Richard Feynman. He had just helped rebuild one of the most successful theories in the history of science. He could calculate the magnetic moment of an electron to 10 decimal places. He could explain rocket engines to 8-year-olds and quantum field theory to other Nobel laureates. And yet, standing there, he was telling the world that the thing he had spent his life working on, the thing he was about to receive the highest scientific honour on Earth for, was something he did not actually understand. He was not being humble. He was being honest. And for the next 20 plus years, until his death in 1988, he kept asking the same question he had been asking since his graduate school days at Princeton in the late 1930s. Nearly 50 years of one of the sharpest minds of the 20th century, returning again and again to a single problem. He never solved it, and neither has anyone else. This is the story of the question Richard Feynman could not answer. And once you understand what the question actually is, you may never look at the world the same way again. Most people who know the name Feynman know him for the funny stories. Cracking safes at Los Alamos, playing the bongo drums, teaching himself to draw nudes in his 50s. But underneath all of that was a physicist who refused to lie to himself. He had a personal rule. The first principle is that you must not fool yourself, he used to say, and you are the easiest person to fool. So when he turned that rule on quantum mechanics, the most precise theory humanity has ever invented, he found something disturbing. The math worked. The predictions worked. We could build transistors and lasers and MRI machines on the back of it. But the moment you asked, what is actually happening, the answers stopped making sense. To show you what he meant, Feynman kept coming back to one experiment. He called it the heart of quantum mechanics. He said, in reality, it contains the only mystery. The experiment is called the double slit experiment, and on the surface, it sounds boring. You take a wall, you cut 2 narrow slits in it. You shoot something at the wall, one tiny thing at a time, and you record where each thing lands on a screen behind the slits. That is it. That is the entire setup. Thomas Young first did a version of this in 1801 with light. He saw stripes of bright and dark on the screen, the classic interference pattern. And he concluded that light must be a wave, because only waves do that. For about 100 years, that seemed like a settled answer. Then physicists did something that should not have changed anything. They turned the brightness down, way down. They sent through the slits one single particle at a time, one electron, then another, then another. Each electron leaves a tiny dot on the screen, exactly the way a particle should. So far, no mystery. But then you wait. You let thousands of electrons go through, one at a time, never two together, never able to bump into each other. And slowly, dot by dot, those individual particle hits arrange themselves into the same striped pattern that waves make. Each electron, all by itself, somehow knows where the other electrons are going to land, even though they will not be fired for another hour. Each single electron, travelling alone, behaves as if it went through both slits at once and interfered with itself. Now, here is where Feynman would lean forward. Because the obvious next question is, fine, let us just watch which slit each electron goes through. Put a detector at the slits, catch it in the act. So physicists did. And the moment you place a detector that can tell you which slit the electron passed through, the stripes vanish. The interference pattern dies. The electrons start behaving like ordinary little bullets again. The act of looking changes the outcome. Not metaphorically, literally. This is wave-particle duality, and this is where every honest physicist, sooner or later, runs out of words. Feynman tried to find a deeper explanation. He invented a whole new mathematical machinery called the path integral formulation that says the electron does not take one path or two paths, it takes every possible path simultaneously, weighted by something called a probability amplitude, and the paths add up to give you what you see. This works. The math is exquisite. He won his Nobel Prize partly for it. But notice what he had done. He had given a description so accurate that we can build the modern world on it. He had not given an explanation. He knew the difference, and it bothered him for the rest of his life. In his Cornell lectures, he warned his students directly, do not keep saying to yourself, but how can it be like that? Because, he said, you will get into a blind alley from which nobody has yet escaped. Nobody knows how it can be like that. Read those words carefully. This is not a young researcher complaining about a hard homework problem. This is one of the architects of modern physics, near the end of his career, telling you that the door he spent 50 years pushing on does not open. So why does any of this matter to you, sitting here in the 21st century, watching a video on a screen made possible by the very theory we are talking about? It matters because the only mystery of quantum mechanics is not really a mystery about electrons. It is a mystery about what reality is. The double slit experiment seems to suggest that until something is measured, it does not have a definite location, a definite path, maybe not even a definite existence in the way we usually mean that word. Some interpretations say there are infinite parallel universes, one for each outcome. Some say the wave function physically collapses when observed. Some say the universe is fundamentally information, not stuff. Almost none of them agree with each other, and every single one of them is consistent with the experiments we have run for the last century. Feynman did not pick a side. He thought the honest answer was, we describe what nature does, and we keep our mouths shut about what nature is, until we have a better reason to speak. He once said that he would rather live with doubt and uncertainty than have answers that might be wrong. That, in the end, is the legacy of his 50-year question. Not a solution, a way of standing in front of the unknown without flinching. And maybe that is the real lesson of Richard Feynman, the Feynman lectures, and the strange little experiment with two slits. The smartest people in history are not the ones who knew the most. They are the ones who could look at a contradiction, sit with it for half a century, and refuse to pretend it was solved. The mystery is still there. The slits are still open. Every photon that hits your eyes right now is in some sense asking the same question Feynman asked. We just have not learned to hear it yet. If this kind of slow, honest physics storytelling is what you have been looking for, consider subscribing. We do not chase clickbait here. We chase the questions that real physicists actually lose sleep over. And in the comments, I would love to know, what do you think Feynman saw in that experiment that the rest of us are still missing? Maybe one of you watching tonight will be the person who finally finds an answer. He would have liked that. He really would.